back to this amplify. Yay. So let's go over this for a second here. So the goal today was, hey, can I get this table and describe it with an equation? So this is my x, this is my y, right? My y column, which right now is called distance. My time column, which called x, this is my dependent, this is my independent, right? So we're going to ignore the last column, so just don't pay attention to that right now. So if I asked you to find the constant proportionality, right, the ratio between y and x, well, we would take, I don't know, pick, well, it's already given to us. Well, you can pick any of these pairs. And just to, it's given to us, but play along. So if I take 315, well, the y value is 15, the x value is 3, so that makes the ratio of y to x 5. Right, so that's my constant proportionality, which means that's my unit rate, so forth. So where's my unit rate? Right here. It's not enough just to find it, but also to understand what that says. That says for every second, for every 1 second, I travel 15 minutes, 15 meters, sorry, 15 meters. That's what that says. That's a unit rate. And if I know the unit rate, it makes life so much easier because I now know that if I have x values, all I gotta do is multiply by 5. So even if I gave you more over here, I don't know, 8 would be times 5, 18 times 5. What if it was 185 seconds? Well, times 5 is always times 5, times 5, times 5. So how can I describe this using an equation, right? An equation that I can use to find distance traveled, no matter how many seconds. Well, to get y, right, so let's start reading this. To find y, which is in this case called distance. So to find the distance, what am I doing? Well, I'm multiplying something by 5 over and over and over again. Where am I multiplying? I'm multiplying time, right? So whatever time you give me in terms of seconds, I'm multiplying by 5. So let's say I say, hey, what about 26 seconds? How far would you travel? Well, to find the distance, I'll take 5, constant proportionality, multiply by the time, and in this case, it's 26. And you find the answer. What if somebody gave you, I don't know, 39 seconds? How far did you travel? Well, let's look at this formula here, right? This formula. And we're going to say, well, I want to find the distance. And in order to find the distance, I'm going to take the number of seconds and multiply it by 5. And you get whatever you get. And that's pretty much, that was our lesson, our objective today. So, did we do this? No? Well, let's do it now. A performer expects to sell 5,000 tickets for an upcoming concert. They plan to make 311,000 from the sale of these tickets. Assume that all tickets have the same price. What's the price for one ticket? Well, so we want the price for one ticket, all right? So right off the bat, we can create a little table. If you don't need to, I'm just saying you don't need to. And we want to make, so I'm going to sell 5,000 tickets, and I'm going to make 311,000. So that's the relationship that's given to me. Right? So now, can we find the unit rate? Well, what's the unit rate? What's this, right? The number here, right? The ratio between money and ticket. Well, to find that, our constant proportionality, I'm going to take, again, this is my x, this is my y. I'm going to take the y value and divide it by x. I have nowhere else to go, so I have to use these two numbers, right? In this case, y, which is represented by the money, is 31,000. And I'm going to divide it by the x value, which is 5,000. So our constant proportionality, right, is going to be 600. What? 6.2. Sorry, $6.20. Really? Sorry, 311,000. So $62.20. So each ticket. So our constant proportionality also this K is our constant proportionality. There's also our unit rate. It's also our price per ticket. So I can come over here and you can say, hey, it's times $62.20. So if I had one ticket only, it'd be 62 times 20 cents, and that would be $62.20. So one ticket, for every one ticket, I pay $62.20. All right, so that's the price. So there's my answer to number one. Here's my unit rate, right? The relationship between the ticket and one. That's the price of one ticket. So what's the price of one ticket? $62.20. Write an equation to represent. So now here comes this part here. What if I had 345 tickets? How much would I pay? What if I had 7,000? No, not 7,000. 1,255 tickets. How much? What if I sold 40 tickets? How do we find the price? Well, we know the price of one ticket, right? So if I had 345 tickets sold, I would multiply that by 62.2. 1,255, I would multiply that by $62.20. 40 tickets, I would multiply that by 62. So now, notice that what am I doing? To find, so let me write, find the total spent, or you can call it Y, right? So I'll write it in two ways. To find the total spent, what am I doing? I'm multiplying the number of tickets times what? 62. So I'm multiplying $62.20 times who? The number of tickets, which I'll call T. And if you write it in terms of Y and X, it's just this. Except that Y has a name, it's the total number spent, right, the dollars. And X has a name, which is tickets. Same thing. Okay. Let me go to the next question. Number 3, what if they make, so number 3 is a little bit backwards. They give us this. What if we make $379,420. How many tickets do we sell? Well, if to find Y, we multiply by 62.2. Well, the other way we can think of as two ways. We can think of dividing by $62.20 or multiplying by the reciprocal, which is 1 over 62.2. So $379,420 divided by 62.2. It's going to give us 6,100 tickets. So to get that, I bought 6,100 tickets, or better yet, that's the number of tickets sold. All right. All right, a car is traveling on the highway. The equation that represents the distance traveled in miles. So here's an equation. They're giving us the equation. So let's understand what this equation is talking about. What does D represent? This, the total distance that you travel. So to find the total distance that you travel, you're going to multiply over and over again 65 times, what does the T represents? The T in hours. So T represents hours. All right? And 65 represents the number of miles traveled in 1 hour. Remember, this guy here is our unit rate. And that guy there is also our constant proportionality. Okay. So what does 65 represent situation? Well, 65. So if I were to create a table right now, ladies and gentlemen, right, and create 2 columns. Let's call this X and Y. The X is the time in hours, and the Y is the total distance. Under time, I'm going to write 1. And under Y, well, I'm going to write 65. So before I even do that, what was the constant proportionality? Times 65. So 1 times 65 is 65. So how do we read this? Well, it reads that in 1 hour traveled, in 1 hour, I traveled 65 miles. So that's what 65 represents. The number of miles in 1 hour. unit rate again. At this rate, how many miles will the car travel? 1.5 miles? Well, if you like the table, you can continue using the table. So we're going to extend this table. Well, a table that in there that you created. So I'm going to put 1.5 over here. So an hour and a half, how much do I travel? Well, to find out, that's easy, right? Times 65. Once you have that unit rate, the constant proportionality is super, super easy. So 65 times 1.5, oops, is going to be 97.5 miles. Look how easy that was. So we're going to do 1.5 times 65, and that's going to give us 97.5 miles traveled. Problem 6 and 7. On his way from New York to San Diego, a plane flew at a constant speed, so the same rate of change. Okay. Over Pittsburgh, St. Louis, Albuquerque, and Phoenix. The table shows the flight time and the distance traveled for each segment. Okay. So from Pittsburgh to St. Louis, it took an hour, and you traveled 550 miles. So what was the speed? Well, 550 miles. Okay. From St. Louis, so we have the, so you know what? Let me ignore this for a second. Let me just focus on these. Do we have the unit rate? I do, right here. Right, and what's the unit rate? Well, we can find that very easily, which is times 550. So I can apply that same thing here, and the same thing here. So let's look at number 2, 1.7. So if you travel 1 hour, you fly 550 miles. What if you travel 1.7 hours? How far do you go? Distance-wise, you go 935 miles. But over here, something times 550 is 330, so obviously we know that instead of multiplying, we have to divide. So 330 divided by 550 is 0.6 of an hour, not even a full hour from Albuquerque to Phoenix. So, okay. Now, how do we find the speed? Well, think about this for a second. Distance is rate, the speed, times multiplied by time, right? So if I want to know how far I traveled, I'm going to multiply the speed times the time. So to find speed or rate in this case, we can isolate r, divide that by t, and divide the other side by t. So if I divide both sides by t, t divided by t is 1. R gets simple. Let me put r on the other side. Otherwise I get confused. So to isolate and find speed, otherwise known as rate, we're going to divide this side by time and this side by time. These two go away because it's simplified to 1. So r's get left over, and r is distance divided by time. So to find the speed of an object, you need to find the distance it traveled over the time it took to travel that distance. So in this case, distance 550 divided by 1. So if I divide 550 divided by 1, right? What do I get my speed as? 550 miles. Second one, I went 935 miles, and how long did it take me? 1.7 hours. So divide those two, and we get the speed, 935 divided by 1.7, and that's going to give us 550. Right. And the last one, you'll notice that if I take the the distance, 330, and divide it by 0.6, you also get, let's renumber, and we get 550, right? Because it's the same speed no matter how far you travel. Let t represent the time in hours and d represent the distance in miles. Write an equation to represent the distance traveled for TL. So the distance, to find the distance that you traveled, what do we do over and over again? We multiply 550 times 2, times the number of hours, which we'll call, which they wanted to call us t. And that's, so if you ask me, hey, what if I travel 5 hours? Well, travel 5 hours, you would go 550 times 5. What if I traveled 12 hours? Well, it would go 550 times 12, right? It's like creating that table and extending the table and using the constant proportionality, right? And multiply it by t. 8, there's more? Yeah. A train travels at constant speed again. Over and over is the same speed, right? That's what it means, constant. It doesn't fluctuate. The train travels 100.5 miles in 3/4 of an hour, 45 minutes. How far does the train travel in 1 hour at this same speed? Okay, let's create a table. So I think creating a table, well, we can do it both ways. So here's what the question is. So if you create a table, right, so far this is what's given to me. Let's call this X, let's call this Y, and X will represent the hours, and Y represents the miles. And they give us this relationship. 3/4 of an hour, I can travel 100, I'm going to change that. 100, no, let's leave it as a, no, let's change it, 100.5 miles. Now they're asking us, hey, what if you travel a full hour? Right, and then obviously we know that they're looking for the unit rate. Well, how do we find the unit rate? Well, how do we find this number here, right? Constant proportionality. 3/4 times what is 100.5? And then we're going to apply it. Well, to find the constant proportionality, remember, we take the y value and divide it over the x. In this case, the y value is 100.5. The x value is 3/4, or if you just wanted to go ahead and use 0.75, that's okay too. So 100.5 divided by 0.75, it's going to give us 134. So it's times 134. There's our constant proportionality, times 134. So I'm going to add one more here. What if I traveled 2 hours? Well, it would be times 134, which gives me 268. And we can add as many hours as we want. Okay. So in 1 hour, what's the unit rate? What's the constant proportionality? The constant proportionality and the unit rate is the same. So we can say 1 hour. In 1 hour, we travel 134 miles. Okay. That's one way of doing it. The other way you could have done this is, well, what if I set up a proportion, 100.5 over 3/4. If you want to use a decimal, if you want, it doesn't matter. I'm just going to keep it as a decimal because everybody's a decimal, makes it easier. So it's 100, that's in miles, that's in hours, right? So I'm writing that relationship. And I'm going to set up a portion this time. So I'm going to go equals miles on top, hours at the bottom. And the question here says, what about 1 hour? How much do you travel? So this becomes our x. So if you cross multiply these two, 100.5 times 1 is just 100.5. X times 0.75 is just 0.75x. I divide both sides by 0.75, divide this by 0.75, and notice that the exact procedure, right? So x, if you divide 100.5 divided by 0.75, it's going to give us 134, which is our unit rate. So I can go back to my ratio on top here, right, where instead of x, I'm going to go and take that x out because I found out, and I say, hey, in 1 hour, 134 miles I traveled. It's dealer's choice, whichever one makes it easier for you. If you'd like to create a table, you can create a table. If you want to set up a portion, you can set up a portion. All right, so they want an equation here. So because they want an equation is, what is this? It's making lemonade, drink contains 1/4 cup of drink mix with 2 quarts of water. She prefers a sport drink which tastes more lemony than the recipe of the container. Completed the equation to represent a mixture of cups of drink mix C and quarts of water W that could be more lemony than the original mixture. What in the world? All right, so let's create a table. because it's in terms of the cups C, right? It's going to be, this is going to be the quarts of water, this is going to be the water column, and this is going to be the drink mix. So we know right now, if I have 2 cups, 2 quarts of water, 2 quarts of water, I need 1/4 cup. So the question is, can you, well, let's find the constant proportionality. What happens when I have just 1 quart? 1 quart of water, how many cups of mix do I need? Well, to find the constant proportionality, again, which is K, so I need this guy here, times something, right? Times something, there's my unit rate. So with 1 quart, well, let's use this guy, because it's the only relationship I know. So we're going to go 1/4, that's the y value, this is x and y, divided by 2. Okay, 1/4, it's a complex fraction, so think about what you did last year. 1/4, so let's write it this way, 1/4 divided by 2. So that's the same thing as multiplying by the reciprocal of 2, so 1/4 times 1/2, and we get 1/8. So if I have 1 quart of water, I'm going to need 1/8 cup of the mix. So what's our constant proportionality? 1/8. So let me write times 1/8 here, times 1/8 here. So what if I had, and 7 quarts of water? How much of this mix do I need? Well, you're going to multiply that by 1/8. What if I had 12 quarts of water? Well, we're going to divide that by 1/8. What if I had 3.5 quarts of water? Then I would multiply that by 1/8. So it's time 1/8, time 1/8. That's our unit. So we know that 1 quart is 1/8. So depending on how many quarts you're using, you also multiply all that by 1/8. So to find out how much of that mix that you need, what are we doing to the water? We're multiplying all the quantity of water by what? By 1/8. Okay. Complete the equation to represent the mixture of cups of drink mix C and quarts of water that would be more lemony than the original mixture. What does that mean? So this is the original. The original says, hey, if you want to make this particular flavored milk, lemon juice, lemon sports drink, that's what you make. So if you want it stronger, well, you can make the fraction, I don't know, 1/5, 1/4, anything that's greater than 1/8 to create a more lemony flavor. Take what they want. That's what they want. Okay. Select all the tables that represent a proportional relationship. So if they represent a proportional relationship, right, they have the same constant proportionality, same ratio between the x and y. So however, another way of thinking of it, whatever, half, whatever you're multiplying x to get to y, right? So, and all we gotta do is find the constant proportionality, and we're really good. All right, so let's do 8. Define a constant proportionality here, right? Define a constant proportionality. Remember k, right over here, k equals y over x. So select a pair. Right, so select a pair. I don't care who you use. 1/4 and 1/2, 1/8 and 1/4. So select a pair. 1/4. So 1/4 and 1/2. If we select this guy here, we're gonna divide half divided by 1/4. That's gonna change the multiplication. We're gonna take half and multiply by the reciprocal of 1/4, which is just 4, and half of 4 is 2. So according to this, the constant proportionality is 2 times 2 times 2 times 2. Well, we got to confirm. 1/4 times 2 is a half. 1/8 times 2. Think about 1/8 and double that. Do you really get a fourth? Yeah, so this works, this works. If you have 1/16 and you double that, do you get 1/8? Yes, you do. So this is proportional. This one, and again, I'm going to find a constant proportionality. So let's use this guy over here. And this time around, to find k, we're going to divide 1/4 divided by a half. That's what that says, right? Y over x. Well, that's division, so we get 1/4 times the reciprocal of a half, which is 2. And 1/4 times 2, think about it's 2 over 4, right? Because 1/4, which is the same thing as a half. So, what's our unit rate? It's a half. So it's a half times a half, 1/4? Yes, it is. It's 2 times a half, 1/4? Think about that. 2 times a half. Is that 1/4? No, it actually equals to 1. So it fails over here. So think about the next one. 3 times a half. Is half of 3 9? No, so it also fails there. So this, right, it's not the same concept of proportionality that's being used. Okay, so this is not proportional. From here, let's find our concept of proportionality. So let's use this pair here to find a constant proportionality. We're going to take the y value, which is 2, divided by the x value, which is 4, and we get that it's a half. So 4 times a half, or half of 4, is 2. That makes sense. 8 times a half, or half of 8, is 4. That's good. So this is good. This is good. And then 12 times a half, or half of 12, is 6. It's good. So this one, the constant proportionality is a half, a half, a half for all the pairs. So this is proportional. Well, last one is easy, right? So it's times 4, which means this should be times 4, and which means this one's times 4. That's a check, that's a check, and that's a check. So that one is also proportional. Okay. Is 4.5, I don't know if you, 4.5 a solution to the equation 1.5 plus x equals 6. Let's solve it. So to solve an equation, we want to isolate the variable. So somehow you have to make this equation look like this, where x is all by itself. In order to do that, let's split the equation into 2 parts, the left side and the right side. I need to get rid of this 1.5, and how do I do that? Well, I can't just throw it away, so I'm going to use inverse operation and subtract 1.5 from this side. Because it's an equation, you want to keep things balanced. If I subtract 1.5 from the left side, I'm going to subtract 1.5 from the right side. 1.5 minus 1.5 is 0, which means those two go away. And guess what? X is all that's left over, which is what I want. And 6 minus 1.5 is 4.5. So the solution to this equation is 4.5. Is that right? Yes. I think I complicated things here. Another way you could have done it, or the way I think you should have done it, here's the equation, and they said, is 4.5 a solution? If 4.5 is a solution, it meant that when you replace the x with 4.5, our expression on the left side would equal the expression on the right side. Well, 1.5 plus 4.5 is 6, and does that equal the expression on the right side? It does. So, check. The answer is yes. Or you could have solved the equation, same thing. Not doing the reflection, you just do that. And that's it.